So, dear participant, today is last session of this 1 month comprehensive bioinformatics workshop. So, we have a couple of things to discuss. First, we thank from our bottom of heart for participating in this Decode Life workshop. Second, we will share all the materials in a folder to your email, same drive link which I have already shared. Third, please fill out the feedback form of the workshop so that we can improve ourselves. Fourth, we invite you to connect with us and further our course of affordable bioinformatics. Fifth, we will send you certificates to your email soon in next 2 to 3 days. So please have patience for certificate. And last is we invite you to participate in our upcoming bioinformatics workshop, that is drug discovery and development. It is again a 1 month bioinformatics workshop and fee is same, that is rupees 1200 and $25 for international participants. Also, we will keep the WhatsApp group active for information sharing purposes. So with these words, now I am handing over session to sir. Over to you, sir.
Yeah, thank you. Okay, so Praveen, I think now we can just straight away going to start the session. Let me just share my screen first. So all of you have the file which is called testdata.csv.
Sir, I have already shared the data set provided by you in the drive link session 21 folder, and also mention it on the WhatsApp group.
Okay, so all of you need to open the Jupyter notebook. Just hold on. Okay, all of you need to open the Jupyter notebook. And keep your file, whatever the file that has been shared with you, in the same directory. Let me also share my screen now. Okay, so today what we are going to do is we are going to do a mini project kind of thing on the data that has been shared. Okay, so this data, if you see this data, you will find that it has many columns stating as F1, F2, F3, F4, so on and so forth. And then there is a last column which is called Y. Okay, so see, if you have something to say, maybe you can directly unmute yourself and speak, because I'm not going to right now see the chat box. Okay, somebody is writing on chat box. Screen is freeze. No, I think it's fine. Is it okay?
It's fine, sir. You have not written everything.
Yeah, I have not written anything. Okay, so yeah, so there are columns which are related with, so we will see the data. We'll see the data and then we will talk about the data. So the first thing is that we will include some of the library that we are going to use in this program, or that these are the very common things that we have already done now. So pandas, I think the most important one that we need for this, and we need to say import pandas as PD. Okay, so next thing I'm going to do is to read the file. Voice is not coming. Dr. Sandeep is saying that voice is not coming, but
it's fine, Dr. Sandeep, it's fine. Maybe your local internet issues.
So now I'm going to read the file. WB is equal to read PD dot read underscore CSV. Okay. So guys, I'm not seeing right now the chat box. Okay, so if you have anything to say, just unmute and say it's okay. CSV and test selected this comma index, because otherwise it will just add unnecessary index. So we have read the file. All of you need to repeat this command with me. WB is equal to PD dot this. And then if you want to see this file, so say WB head, and this is my data. Okay, so now we can see that F1, F2, F3, and so on and so forth till F119, and all these are features. Okay, and then there is something called while. Okay, so actually what is this while? I'll tell you, though it is not required for this session, but this is a kind of toxicity for each chemical. Okay, so so what we are going to do is we are taking a compound, let's say the first compound, which is at the 0th index, and we are calculating 119 features. Okay, so these features could be anything like number of hydrogen bond, or sorry, number of hydrogen atom, number of carbon atoms, or aromatic rings, or maybe the molecular mass. Okay, so it could be any such property of a compound. Okay, and we have calculated 119 such properties, and that properties we are going to link or relate with the toxicity of a molecule, because we know that whenever the molecule or any compound is toxic, it has to do with its structure, right? So, and this is actually called QSAR in some other term. Okay, so this toxicity is related to the structure, but I'm not going in the detail that how I have calculated these values, but these values have been calculated and shared with you. Okay, now we need to develop a model, and in this session we are going to develop a regression model, which I think all of you already have seen it in your past classes. So, but before going for for building a model, what we need, what we need, what we need before building a model, what do you think is required? Yes, so if I'm asking any question, I can see the chat box. No one. So before, what should be the first step? No, it is training and test will come later on. What is the first step when you have a data? What is EDA?
Exploratory data analysis.
Okay, okay, that's a very fancy word, but what you
So
need?
we have to look at the data, how many columns are there, how many rows are there, if NAs are there, duplicates are there. So all that we have to look at it. If any outliers are there, so all that visualization and all we have to do.
Okay, okay, I think you are correct. Harshita or was there Bharti? So yes, so this is also called data pre-processing. Okay, so let's first say this. Okay, this is just the first line is just to say that how many rows you want to see. I want to see 4,000 rows, because if you don't say, it will just curtail your screen whenever you know output anything. Okay, you know that. What I'm trying to say is, if right now if I say WB, so it will, can you see this 0 to 4 and then 353, all the data in between are dot dot dot. Okay, but if you want to see all the data, so you say PD dot option dot display maximum row, max underscore row is equal to 4,000. I mean, you can say no, 4,000 is not required here, 400 will work. So 400. And then now if you say WB, it will take some time, but it will show you all the data. Okay, so you can see all the data, but this is just all the rows. You can also do the same thing with the columns. Okay, but that is not the big thing which I wanted to say. So the thing which I wanted to say is the data pre-processing. Okay, so suppose I'm saying WB dot is NA. It means that is there any NA? If any NA, then you just spell it out. Okay, so if you just do this, it will show you all the columns, and it is false if there is no NA. It is true when there is NA. So can you, so all of you I think must be doing this, because this is a mini project, so we all are going to do this exercise. It's not like that I'm doing it and you are just watching it, so we need to do it. So tell me that, is there any true value in this? And if there is any true value, what is the name of that feature? Yes, NA are there, but what is the value of feature? If you can tell me the value, it means that you are doing it. Which column, like F1 has false, means it doesn't have any NA. F2 is also false. Which one is true? Somebody is saying 113 and 115. Anyone else? 113, 15. Okay, so I will just go down and see where is true. So yes, 113 is true and 115 is also true. It means both these columns are having NA. Okay, so, and of course we don't want NA, right? In our data set, we don't want any blank. So what we can do multiple things. This time what we are going to do is we are going to replace it with the mean. Can you just replace it with the mean? We have done this exercise before, so I think you can replace it with the mean. What you need to do, you need to say WB dot fill NA, and you want to fill this with what? WB dot mean. And whatever comes, you want to reassign it back to WB. And this is the command. And now if you see WB, let's see it. Okay, one interesting thing. You can see the WB or the entire WB, but the interesting thing will be to see the shape. Okay, so let me just do it from the beginning. Okay, so I read the file again. And what is the shape? Right now, there are 120 columns and 358 rows. Okay, this is just a NA. So it will show me the NA. I'm not running it. I'm just replacing the NA with the mean value of that column. Now I can just run it back. Is there any NA? And let's check 115 and 13. Now it is false, right? It is false. It means that it has been replaced with the mean value. Okay, and what will be the shape? So initially the shape was 358 120. What will be the shape after this? Tell me. Same, yes. So it was just a trick question. it will be same, right? Because we have not done anything. In fact, we have populated something which was missing. So definitely it will be same, right? Now I'm sure that, okay, my data does not have any blank value, otherwise it could be a problem. Now the next thing is, after inserting the blank, the next thing is to fill, to find out, is there any constant column or not? Okay, so is there any constant column or not? So why? Because if your data set is having any constant column, okay, so then it will not add any value to your model. Okay, in fact, it may try to confuse your model, because for that column every item values are same, right? So it means that for all the compounds, is there any feature which is having the same value? If it is so, then it is not discriminating one compound from another compound. So we should not keep it in our data set. Okay. Okay. So there is a very small but logical way to find it out. So see, this is the command. So what I'm doing is, okay, maybe I should just go step by step. So what I'm saying, data frame column. Okay, so let's say column is F1. Okay, and dot unique function. Is there any F1? Yeah, I think it has F1. Just hold on. That it is F1. Data frame. I think I should just use dot. Data frame is not this. Sorry. It's WB. I'll tell you why it is data frame, but WB F1 dot unique. So can you see this? The F1 feature has only these number of unique values. Okay, and if I add len, so it will tell me the length of the, means the number of items which are unique, so which is 3 for F1. So how can I relate it with, if I want to check it's a constant column or not? What will be the logic? If you understand the logic, then coding part is always easier. So how to find out whether a column is a constant, looking at the code which is given in 17th block? Yes. How can you find it out whether all the columns value are same or different? Anyone want to give a try? Length is equal to 1. Yes. So if you compare this equal to 1, okay, so it is false. But if you compare it and it comes true, it means all your values are same, right? So I'm applying the same logic, and because we definitely have less time, so I'm not going to type it. In fact, I'm going to just paste it here on your chat box. And this is very simple. I just created a function, okay, for dropping a constant column. So if it is a constant column, I'm going to drop. So what I'm doing is I'm first creating a copy. So this data frame is whatever the data frame you will supply it to this function. Okay, so initially, and I'm going to supply WB first. So it will make a copy of that and then start reading your column, every column. Okay. And this is for column which is iterator in a data frame dot column, which is your data frame dot columns means all the columns. And then the first time it is saying whether it is equal to 1. If it is true, then in result, okay, in result, it is dropping that column. So for dropping any column, you need to give the name of the data frame dot drop function, name of the column, and access equal to 1 if it is a column. Okay. And then it is revert or it is returning it back. The data frame, which is now clean, it means all the constant columns have been removed. Okay. So you need to execute this block, and then suppose I'm saying WB is equal to drop constant, and I'm passing this value WB. Okay. Now, all of you need to run this code. I already pasted the bigger one in the chat box, okay, to save time, and the logic is very clean. So I just illustrated the logic, and then the code part is not very difficult, only the syntax thing. You do this and tell me what is the shape now. And I want to see that. Just run it once and tell me what is the shape. Earlier it was 358. Okay, somebody is saying 358, 119. At least 3% is saying. Anyone else? 118 or 119? Okay, so all of you need to do this. I strongly, believe that all of you need to do this. This is something that you have to do, and then you will understand. Otherwise, there is no point of project. It's not a lecture or a PPT thing. Okay. So what is the value coming after saying WB dot shape? Only 3% have written anything on the chat box. Okay, the fourth one. What happened to others? Okay, if you are not trying it, can you let me know that if you are not trying, so that I will not expect. I'll go forward. Okay. 350. So everyone is getting 358, 119, other than these 5 people. Okay. All of you are getting the same value. Okay, let me also check what value I'm getting. Yeah. So this is the value. Okay. Now this is the second step. So first step is removing all your blank or NA. Second is dropping your constant. Third, there could be many. Okay, but I'm just following some of the very standard data pre-processing part. The third one is saying dropping the quasi constant. Okay, what is this quasi constant? Suppose your okay, right now you all have to listen. So quasi constant is also something that you need to remove. Very nice, Bharti. I've seen your result and it is correct. So quasi constant is a column which has, let's say, all the values are not same, but most of the values are same. Okay, so suppose there are right now we have 358 compounds, and for all these compounds there is a feature called F10 or whatever. 90% of the compounds are having the same value, let's say any value. suppose 55, and 90% of the compounds are having the value 55 for this feature F1. Okay, so once again, this is something which may, I mean, we are not sure whether it is going to confuse your model or not, but definitely not adding any value. Okay, because for 90% of your um, data, the features are same. Okay, so if 90%, so suppose somebody asked me to discriminate between male and a female, and I'm saying number of hands, and number of hands are 2. Okay, so in this case, like until unless somebody is handicapped, the person will have 2 hands. But suppose there are few handicaps also in my data set. So, but we all know that maybe handicaps population would be very less, maybe just 10% or 5%, and most of them will be having 2 hands. So this is not going to classify between male and female. So this is not actually a relevant feature. Okay, so if it is not a relevant feature, we need to get rid of it. Okay, so that we will not create any mess at a later stage. So right now I'm going to type something in your column, in your chat box. This, you need to install this fast_ml, because these are the libraries I'm going to use for getting rid of your quasi constant. Okay, once you do this, import, you need to import it, these 2 things. I will also import fast_ml.utilities import display all, and I think the get constant feature is the key thing. So you first have to install this fast_ml library and then import this get constant feature. Okay, so this installation doesn't take too much time. So how many of you have done this? Okay, just one. Yes, yes. At least this one you can say yes or no. All these are the same name I have seen before. Anyone new? Okay, this is new. Francisca. Okay. Samhita, Kaushik. Okay, so all of you, I think, or most of you have done this. Okay. Now you call this function. By the way, you call this function get constant feature. Okay, put a double, put a this braces. If you want to know about any function, you go inside that parenthesis and say shift tab. Okay, so all of you can see this. There is a description of this. So this is a small description. If you click this plus sign, it will be expanded. Shift tab, or you can just scroll it down. You can go down and see what it is. Okay, but luckily it doesn't have so many arguments. It has only two critical argument. One is the data frame, which data frame you want to use, where you want to drop the quasi constant, and what is your threshold, that how many, what is the percentage. So this is a fraction, right? So if you convert in percentage, so 99% of the data, if it will have the same value, then it will drop that particular, or tell you at least. Okay, so let's use it and find it out how it works. Okay, so WB, somebody is on not mute. WB and threshold is equal to, let's say I'm saying 0.9. Okay, 90. So it means, and I'm getting something which I'm storing in quasi constant. Get quasi constant got and it's a threshold. Okay, so now if you see, run this command and see this quasi const variable, what it is showing to you. Very interesting thing. I will also look at it, but I want all of you need to first do this. And if you can tell me, it means that you have done it. What do you see after seeing this quasi constant? Anything means any part of the output you can write, or you can just write your own words. Or somebody has switched on the video. I don't know whether it's deliberate or not. Okay. So few people started getting getting the result, and it's absolutely correct. And you can see this. If I put a threshold 0.90, all these features, which is right now in front of me, somebody is also getting error. Okay. Jinkwan, you are getting the error. Get constant W threshold is equal to 0.9. What is the, I don't know, maybe something wrong when you are importing the data set. But here, what is interesting, it is saying that these all are quasi constant if you put the threshold 0.90. Okay, because F74 has 98% of the data, which is minus 0.11. Okay, which is huge, right? And then you can always play with the percentage. Okay, so suppose I'm saying not 90%, let's say 98%, and then once again I'm running it. So there are 7 such features which are having more than 98% of the same data, and that definitely I don't want. So what I need to do, I need to drop all these. So WB dot drop, as I said. So there are multiple columns, so you can just write. Okay, let's see that how you can do this. So what I want F1, F74, F78, 84, 91, blah blah. Okay, so I would say quasi constant dot var. So it will tell me, it will give you the name of the feature, and then I will just use it with the drop function. So WB dot drop. Now this is, as I said, drop function has the first first argument, which is the name of that column. Okay, and what is the name of the name of that column? It is all these, which is coming from quasi constant dot var. Okay, and I can just say drop it. Okay, sorry. And say access equal to 1. Now, sometimes you feel that even if you miss a single thing, your program is not going to do it on its own. Okay, so x is equal to 1. So it is dropped, but it is not saved. So let's save it back to You can also use in place equal to true, but I believe on this. So this. So now WB, these 6 columns are gone. Okay. How can you check it whether it's gone? How can you check it whether it's gone or not?
Data dot shape.
Data dot shape. Okay. Do it and tell me what is the shape now. Okay, tell me what is the shape.
358 into 112.
Okay, you can type it. But is it saying that, okay, 112 any it should be 112. It should not be 119. If it is 119, it means it has not dropped anything, or you did not find any quasi constant. Okay. And you can also check whether these are gone, these specific features has gone or not. So I can just run this command once again. Okay. And see this quasi constant once again. Now I don't have anything, and it should not be there because I have removed if there is any 98% similarity. Okay. Now, as you see that from 120, I started with 120 and I reached 212. Okay. Now the last thing, okay. The last thing in the data processing that we are going to do is to remove the correlated data. Okay. So what does it mean? So let's first give a minute or two on what it is. So it means that if your data set has 2 columns which are correlated with each other, okay, then of course you don't need both of them. Okay, you need only one at least. Or if there are 8 such column which are very highly correlated, so you don't need 8 of them, you need only one. Okay, so a true representative of your data set. Okay, you may keep it, but it is always advisable that you just get rid of the correlated one. Okay. I mean, there is some logic, some concept called data cursing. So when you have lots of data, that is also like a curse. Okay, so don't think that if you have more data, it is always a good thing. Okay, so there is no need to cut your data until unless you have a solid reason behind it. So like this reason is very much logical, and you should just get rid of it. Okay, so for getting this, what we will do is WB dot core. Okay, so this is, if you write this, this is a fantastic function. It will give you the matrix of correlation. So F1 with F1 is of course 100%. F1 with F2 is very less. F3 is this much and this much and that this. Okay. Now, this is what I'm going to use. That's why I just use this function, because I will put a condition that if the correlation is greater than, let's say, 0.8, I would believe that both these functions are same, and that's why I will just remove both the features are same, and that's why I will remove one of them. Okay, so once again, I'm just not typing it, the function, as I have done this for dropping the constant. This time again, I'm pasting it on your chat box, copy it, and it is very simple. Once again, we will see it, and you can also understand it. Okay, so this data, what is correlation matrix, is this. You just need to do this before. Correlation matrix is equal to WB.core, means It has created the matrix and stored it in this correlation underscore matrix. Now I want to know the name of the features that I need to drop. Okay, the very similar way that we have done for quasi-constant. What we have done, we extracted the name of the features that are following that threshold criteria. Here again, I will find it out the name of those columns which are having one or more columns with greater than 0.8 correlation. Okay. Notice that here I'm using absolute because, you know, -8 and -9 and -0.9 and +0.9 both has to be dropped. Both have to be dropped, right? So here what I'm saying is you read the matrix, whatever the number of the columns, 0 to that number of the columns once again. And every time you are comparing it with the next, it is just a simple two loop system, right? This is the inner loop and this is the outer loop. So first column is getting compared with all the first value is compared with all the respective values. And whenever yes, I was right, like first column is getting compared with all the columns, and if the code, and every time the correlation, because I'm reading the correlation matrix, right? So if the correlation matrix is greater than 0.8, I'm saying just add that column name to my this set called correlated features. So run this correlated features and you then see this correlated features. It has many of them. Okay, so okay, just increase it point, let's say if it is 0.9. Okay, you can see that correlated feature dot, I don't think that shape would work. What is that? Len, I think len would work. Yes, so 59 I found when I put a condition 0.8. Suppose I put a condition 0.9, then 26, of course, because now I make the criteria a little bit more stringent. So the chances of following that criteria is now difficult. So only 26 of them followed it. And once again, you just copy this one and paste it here. Just instead of quasi constant, you put this correlated feature, not dot var. Dot var is of course not required. And I dropped all these 26. If you see now wb dot shape, now 86. So now this is something, now I have clean data set. I don't have NA, I don't have constant, I don't have quasi constant, I don't have correlated data columns. So this is ready to go for your model building. Okay. In fact, I should have done one thing before. I should have removed the y variable. Otherwise, what if the y variable itself got correlated with something and gone? Okay, so but I don't think that it should be there, because there won't be any features which will be highly correlated with my y. Yeah, it is there. But guys, this is you know, you should just separate the y before and drop the y from wb. Okay, and later on you can either add it or you can use it separately. So what I'm saying is this thing, maybe you can do it at the very first step. We are lucky we did not lose the y after doing all the data processing, because y is not a part of your data processing, should not be a part of your data processing. Okay. um, yeah, fine. So variable underscore y is equal to wb dot y, and then I would drop this wb dot drop y axis is equal to 1. Y is not defined. Is yeah. It is dropped, but it is not saved. So let me just save it back. Okay, now it is dropped. So if you want to check, you can check that WB does not have Y. Okay, now it does not have Y, but why it has 119? This 119 should be dropped, right? Okay. This is surprising. Why this 190? Maybe it is not all 1 or 0. Yes, there are zeros. That's why it is there. Okay, I thought there is all values are 1, so why we still have it, but there are values which are 0 anyway. Okay, but this column I have created on my own. Okay, 119. So let's drop this. Okay, I mean, this is just to demonstrate something. I created it. It's actually not there. So I'll drop this F119 axis equal to 1. So this. Okay, so now that is gone. Now, very easy, because you all have done this just recently. I have seen your notebooks, and I saw that you guys have recently done it. This regression thing, and this is very simple. So here I would not, put lots of effort, because this is just, I think, 2 or 3 days back, or maybe a few days back. So this is all the library that you need to import. If you need to do this, then this copy and paste on your command on your block and cell. And then first thing is now split it. Okay, so now if you want to split, you need to split your WB, because it has all the features, and your variable Y, because it has the predictor Y. Okay, and you guys have done this training and test split, so I will also not waste your time. Let me know if it is not clear, but this is very, I think, must be very clear to all of you. Okay, this chat box is creating a problem for me. It is coming in front. Okay, random state 1, I'm saying test, and test size should be 30%. And then it is, what is my X variable, what is my Y variable. So it will generate X train, Y train, X test, Y test. Okay, Y variable, test variable Y. Okay, and then X train and Y train is created, and that I'm going to use for the model fitting. Of course, the model fitting is something where in linear regression, you don't have so much of choices, but when you are doing a little bit complex algorithm, maybe like random forest kind of thing, then you have many optimizer, especially in neural network, and then you fine tune it. So that maybe you can do it when you are exactly doing it on any other model. So right now we are just taking the linear regression, and this fitting it, the X train and the Y train. So you first declare, so this is called creating an object, and then that object need to be used to fit your data. Okay, so maybe I should just copy and paste it here. So this is your train and test. This is your model. Okay, and then you say this, so it is fitted and the model is created. Okay, now if the model is created, we must check the value of this model, how it is doing it on my data, on the test data. So let's say y underscore pred is equal to model dot predict. Predict is the function, and it needs your X test. Okay, so y predicted is created. Okay, you can check this y predicted. So these are the toxicity of the molecule which is being predicted, but you need to compare it with your original value, because this is just a test set, internal test set. So we know the original value, and we can calculate mean absolute error. Mean absolute error can be calculated using the function called mean underscore absolute underscore error. That is also, you have done it. So I've seen the notebook. So mean absolute error, and then you need to give y underscore test, comma, and y underscore pred. And see, this is 0.639. Okay, mean absolute error is 0.639. And the other thing that we also need to check when we are going for regression is the correlation coefficient. For correlation coefficient, once again, I'm going to use a inbuilt function here. This function, Pearson R, means Pearson correlation coefficient. So these are very easy. So this is when you are using this Pearson R, it is taking definitely your y test and y pred. What is the correlation between test and predicted that you want to know? Like you already calculated the mean absolute error between these two. You want to know the correlation. It also returns you something more, which is called p-value, means whether the correlation is significant or not. But right now, I'll just leave it. But let's see the correlation. I pasted this command and check this correlation. 0.585. Okay, so this is not very good. Okay, but this is what I was expecting, because this is just a simple linear regression. And now what you can do is because your data is prepared, now you use random forest. This is not I'm going to do today, but this is just a suggestion for all of you, that now the linear regression is giving you 0.585. Use decision tree and see, or use random forest. Random forest is my favorite, so you check it out, what is the correlation it is giving. So if you reached, let's say 0.75, 0.8 kind of correlation, it means that using the features of those compounds, you can predict the toxicity. So suppose tomorrow if you get, so if there is comma and then something like this, it means, okay, so it will be clear that if you just run this command, so it is returning you two things. Okay, so it is returning you two things. I think I should write just P. So in correlation, it is storing the first return value, and in P, it is returning the P value, which I'm not right now going to discuss. It's a whole statistical concept. And then I'm printing the correlation. So it means whenever your function is returning to value, this is the way you write in. I think you know this. Okay, so now you check, do the same thing with random forest, do the same thing with maybe decision tree. I don't know, neural network if you can try, but that is not required. I think do it with the decision tree and random forest and check how it is coming. Your correlation is good or bad. Okay, now you can also play with not dropping the constant, or maybe you can increase the correlation matrix value, do all kind of these kind of manipulation or this kind of trial with your run, and see how it is changing your final outcome. Okay, and see when you are getting the maximum correlation. Okay, at least first with the linear regression itself, I believe that you can get rid of get a little bit higher. Okay, suppose I'm saying 0.99 here, and here also 0.99. Okay, and just say restart. So this is just before we are ending this session. I just changed a couple of things and run everything once again. Run all the cells. You have seen that I have just made it 0.99. So it is still 0.55, which is bad than what we got earlier. Okay, so you can play with these things and find it out what is and you guys already have done that, how to get the best features and use the optimum features. This thing I think you have already done it in previous classes. Okay, so I'm going to share this workbook with all of you, notebook with all of you, and then maybe you can try and find it out. What are the different possibilities with the linear regression itself? And then maybe later on you can do with the other function. Okay. Okay, so anything now, because we are going to end the session now.
Sir, you are not going to end the session. You are going to end the workshop also.
Okay.
So this is the these will be the final words from your side as well. If any participant want to say something.
Yeah. Anything anyone wants to say? I mean, let's keep it general. This is just a last couple of minutes we have, so let's keep it very general kind of conversation.
Sir, how can we convert our data into the file format as you share?
Right.
Sir, today.
Right function.
No, sir. Actually, we collect the data on the some IC50 values. But sir, can.
Yes.
एक्चुअली सर जो फाइल फॉर्मेट आपने शेयर किया है टॉक्सिसिटी फॉर्मेट में, उससे पहले भी कुछ कोड यूज किए होंगे आपने, वो हम अपना जो डेटा है उसको कैसे उस फॉर्मेट में ला सकते हैं?
नहीं, वो तो CSV फाइल फॉर्मेट है, कॉमन एक्सेल फाइल है, ये तो आप अपने एक्सेल शीट पे बना लो ना।
नो सर, नंबर ऑफ रोज आपने कुछ प्री प्रोसेसिंग तो किया है उसमें?
नहीं, पहले कुछ नहीं किया है, जो है आपके पास वहीं से स्टार्ट किया है। आप अपने डेटा को रोज और कॉलम में डाल लो manually and then you start doing it. Okay. Or anyone else? No. Or we should just end the session. Okay, Jingquan, I have a question for you. So from where you are?
Yeah, originally I come from China, but I'm working in Germany.
Okay, okay.
Yeah.
Okay, great. Because I've seen lots of your responses on chat box. So that's why I thought, to ask you that from where you are. Okay, and anyone else wants to say anything else or something regarding the workshop? How was it? Anyone? Okay, so they are saying thank you. Okay, okay, so
I think most of the participants are introvert.
no, maybe they don't have right now anything to share, but I hope that you will use all these Jupyter files that we have shared in your future work. Maybe you won't be able to apply the same, but something different, you need to do some modification and then you can use it. Okay, guys. Okay, so let's stop it here. And Praveen, now you can end the session and the workshop.
So there is one comment from before concluding this workshop. There is one comment in the chat box which I would like to dedicate Dr. Avinash. Very thorough and rich workshop. So much given for so little. So people, these comments are very valuable to us, and we'll try to improve ourselves, and we will try to bring more new courses to you also. So participants are central to every workshop, and this batch is great, I must say. So with these words, the good life thanks Dr. Avinash, Dr. Satya, Dr. Salman, and Priyanka ma'am for making this workshop comprehensive and wonderful. So thanks Dr. Avinash, and I will share the video recording of this session along with the
I'll share the notebook file.
File as well as the video recording with you as soon as possible, and I will share the feedback form on the WhatsApp group. Kindly fill out the feedback form so that we can release your certificate as soon as possible. So thanks, and goodbye to all with the intention that we will meet again some future events of the code life.
Okay,
So
thank you.
so can I end session, sir?
Yes, please.
Thank you, sir. Thank you. Yes, Dr. Sandeep. Your question, please. Dr. Sandeep. So, Dr. Sandeep, kindly write email to us. We will let you know everything. So, thanks, and I'm ending.